How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a bucket cylinder rod off a PC 1250 Komatsu in to see if we can salvage it. So the first obvious problem is the piston is damaged. It has a huge amount of scoring on the outside of the piston, and that's most likely happened because of the seal design on this particular cylinder. They do have a steel sealing ring, and quite often they do get broken and they pick up in the barrel and then everything gets munted. And the inside of the barrel doesn't look that good either. It is also here to be rebarreled. Not only that, but the piston is actually seized onto the rod, and that is due to the locking system that Komatsu use. They drill and tap a hole in between the threads of the piston and the rod, and then use a grub screw to stop the piston from coming undone. But in my experience, this is not a very good design. This is quite poor engineering. We constantly see this problem with this style of cylinder rod because you have a drilled and tapped hole through an already existing thread. All it takes is a little bit of material from the thread to pick up, and you end up with this problem. And to make it even worse, some people, when they assemble it, they do center punch around the grub screw to lock them in place, but all that does is deform the metal and make it harder to get them undone, where if they'd use the right Loctite, they wouldn't have to do that. And because of that, the choke assembly and the gland can't be removed off the rod. So the rod doesn't have any visible damage on it. The customer has just asked us to linish it, but we don't know if it's bent or not. We also need to reclaim the eye because it is out of spec, but before we do any of that, we need to remove this piston and see if the rod can be salvaged. So we need to get this set up in the lathe, but before we do that, I need to change over to my 4-jaw chuck. So before I can start machining off the piston, I need to set up a steady rest, but first I need to get it running concentric, and I'm going to set up a 4-jaw on the tailstock, and I'm going to use dial indicators to get it running true. So I've got that running to within 0.03 of a mil. Now I'm going to go down to the tailstock and get that a little bit closer, and we might have to go between the two until we can get that dialed in.
Whoa.
So I'm pretty happy with that. We got both ends running to within 0.01 of a mil. Now we can set up our steady rest. So before we spin this, I do need to tape these two together because I don't want this bouncing around on the rod because it'll probably damage the chrome. Now we can get our tailstock out of the way and spin the rod to see if it's bent. So that's all good. We're just going to tape up the steady so we can protect the chrome. Because all it takes is a piece of swarf to get in between the rollers and the chrome and damage it, and you would have to either replace the rod or send it out for chroming. So this is a very quick and cheap insurance to avoid that happening. For added support, I am going to use a live center in the tailstock to push a little bit of pressure on the cushion on the end of the rod, just to hold a little bit of support against it, because I'm really only gripping on two jaws in the forejaw on the headstock, and I don't want the job to walk out of the chuck. To machine this, I'm going to be using our W&MG carbide insert. So we are set up and ready to start machining. I'm not going to machine the entire piston off. I should only need to machine about 30 mil off the end of it to reach the end of the grub screws. Then I can chase that thread on the rod and hopefully unscrew the piston. So the first thing I'm going to do is just machine down this outer lip. Because there is a broken seal ring there and they are made from steel, I need to remove them, otherwise I can break inserts. So that high-pitched squeal you can hear is an indicator that that material is extremely hard. It does look like there is a heat-affected area there. I'd say when they tried to get it apart, they did heat it up. So because of that heat affected zone, it has worn out that insert, so I'm going to try a different grade and see if we can get through it. Using a ceramic here would be pointless. Because of that interrupted cut, it would just shatter the insert.
Oh my god. God, that is hard. It's really buggered that insert.
So we can see through the grub screw holes now, and we've only got about 6mm material to remove. So we're just going to take a little bit easy until we get down to the height of those threads. So that's getting pretty thin. That's as far as I'm going to go. If I try and machine that whole area down, it's just going to catch the insert and make a big mess. So I'm just going to undercut this area here to relieve those threads, and then I can peel it off with a screwdriver. So that's not as bad as I thought it was going to be. I did expect to see a lot more damage, but I can see that the first couple of threads have picked up. So I'm just going to finish machining the rest of that material away to get rid of that grub screw hole, and then we're going to see if we can rotate the piston. How much does it peel off? That's it. So that's good news. The piston does freely rotate on the rod, which means we should be able to just unscrew it. But before we do that, I am going to chase these threads to clean them up. That way we don't have the same problem with it seizing on those damaged threads. Stay. Stay. Up. Almost. Listen. Listen. Drop it.
It's gonna go somewhere.
Come on. Because this is a Japanese rod, it is going to be a metric thread, and it should be a 2mm thread pitch, but we're just going to double check it anyway. So yes, it is a 2mm thread pitch. Now we can set our lead screw. So the way I like to chase threads is I bring my tool close to the job, then I zero my digital readout, I then engage my half nuts, I then use my cross feed and my top slide to get the insert aligned into the thread. Do it again just to check it. Then I take a clean-up cut, and then I can adjust the depth from there. So now I'm just going to do a couple more cuts to clean up those damaged threads until the insert starts to engage on the good threads behind it. And to make sure I don't overcut the threads, I'm going to take it in very small increments. So I'm happy with how far I've chased those threads, but they are not perfect. So I am going to use a wire wheel on a grinder just to remove any loose pieces of material, and then a thread file to clean them up a little bit more. So we've successfully removed the piston and haven't done any more damage to the rod or the threads. Now what we're going to do is remove the little cushion pin. That way I can face the end of the rod and get it ready for linishing. So it does look like there's some retaining compound down that hole. So I'm going to drill that out to get the balls out so we can remove the cushion. that down yet?
Not quite. A little more. Keep going.
Oh,
Oh, I saw
Yeah.
that, yeah. Is that one?
no, need to find them before we go any further.
Oh, jeez. Maybe. Everything looks silver. Oh my god, really? It was just one.
There's two.
Was it? Oh, jeez.
On the other side.
There. Is that it there? Right at the end of my fingernail?
Pick it up. That?
Yeah.
No.
Oh.
Anyway, I can get more balls.
Whoa.
So. So that's not coming out. I think it's because the metal on the end of the rod has been deformed after it mashed everything inside the cylinder, and that is what is holding it in place. So I'm just going to machine a bit of that area away and hopefully relieve it. So that is still quite stuck. I am going to try and lever this out using anything I can. So I finally got that out, and you can see the groove on the inside of the rod and the outside of the pin that the balls go around to retain that pin in place. Now we can get on to cleaning up this end, then getting the gland out of the way, and then we can linish the rod. So that hasn't fully cleaned up, but I'm not going to machine it down anymore. The end is now flat, and that'll be fine. The white metal bearings starting to lose its Teflon.
But that looks okay.
That's fine. Now we've got that out of the way, we're going to set up our shop-made tool post grinder so we can linish the rod. So if you watched our videos on us making our shop-made tool post grinder, you might notice this one is a little bit different. This is version 2. What ended up happening is we got a recurring job from a new customer where we weren't able to spin the diameter and grind the OD. So what we ended up doing was remaking the tool post grinder a little bit different. We got rid of the clamping system that holds the spindle in the front of the machine, and we actually passed the spindle through the body. And doing that gave us an extra 170 mil of reach, which means we can spin those bigger jobs and didn't have to farm them out. Another upgrade we did is I got a friend of mine to machine us up some new pulleys so we could run a serpentine style belt, because you don't need a great deal of power to drive them compared to the double V belts we have on our original grinder. To linish it, we're going to be running the spindle in reverse at 145 RPM at a 2.5mm feed rate. We're also using an 80 grit flapper wheel and running the tool post grinder at 1400 RPM. So you may see and hear that it is not running concentric anymore. That is because we have the center in the end of the rod where that cushion pin was located. And obviously that's not perfectly in the center, but that's not a problem with the linishing. We are using a flapper wheel. It does allow for flexibility with the movement. Righto guys, so that's all the linishing completed. I'm really happy with the surface finish. That's exactly what we want. So this one has definitely been a win. We have managed to salvage the rod. If our customer was to go and buy a new one, it would cost him over $10,000. But now all he has to replace is the piston. We still do need to reclaim the eye, but we're not going to show you guys that because we already have videos on our channel of us doing that. But that's it for this job. Thanks for watching. Let everyone regroup. Oh, fuck, I did it again. Last go.
Yeah.
Then you need to fumble it all together.
Okay.
Right. Oh my god. Oh my god, I've already forgotten what I just said. Fuck, I don't even know what they're called. Am I saying ferry bits? So that's all the balls out. I don't like that. Fuck me. Oh, I didn't like that either. Where am I starting from? So we can get the balls out that hold in that cushion. That's another really shit design.
You pause, your brain shuts off.
We still need... What's even a word? Me no speak. Use little word. Righto guys, so that's all the linishing completed. I'm really happy with the surface fin... Is that it?
No, because you stopped and went, ugh, is that it?
What was after that? Pretty gnarly, eh?
Crazy that one little thing.
Dwarf that's coiled up there.
That's it. That was it.
Handle. I'm trying to get my knee on that.
Oh my god, are you serious? We have to find it. Curtis has lost the remote. Oh my god, man.
Oh. What do you got? You got your chicken? Drop it.
That's not the game he likes to play.
Drop it. Drop it.